Lovely. All right, welcome everybody to our bi-weekly interim. This is the last one of 2024. And this session is being recorded. This is the Notewell, which all of you have seen. All of you are not new to this, but there it is. Okay, as always, we're going to use Zulip for any technical chat. There's a link. There's a pinned message with a link in the Google Meet chat. Everything else will be in Google Meet. So audio, video, slides, obviously, because that's what you're using right now. Queuing, we'll use the show of hands tool or the raise hand tool here in Google Meet. Any sort of meeting logistics chat can happen in the Google Meet chat, but technical stuff should happen in Zulip, partly because not everyone can read the Google Meet chat for policy reasons. And this is also a reminder to click on the notes, which are also in the Google Meet chat. There's a link to that, and add your name to the blue sheets, your name and affiliation. And you might as well keep the notes window open because we need a scribe. We'll talk about that in a second. But start warming up to volunteer right away. This is today's agenda. We're sorry it was a little bit late getting out yesterday. We're going to time box the discussion about removing group order for subscribes, and if Ian shows up, he'll be leading that. And then the main event will be Mike English talking about his joining Fetch PR. Would anyone like to bash the agenda? All righty. Who's going to scribe?
I can do it.
Thank you, Magnus. All right. Ian just messaged me to tell me he was going to be a few minutes late. So, Mike, why don't you get going, and we'll stop you around 9:45 so Ian has time to do his thing.
Sure. Let me pull up the PR.
Many of you have not signed the blue sheets. Please do so. I see 4 names on it. Do you have slides, Mike?
I do not have slides.
Okay, that works.
I have the I was just going to share the PR. Okay. Does that come through? Good. Okay, so this PR 638 is for joining Fetch. It's a follow-up to discussion that we had at IETF 121 in Dublin, where Will Law presented some slides on why we would like this feature. Essentially, it is a way of pipelining Fetch requests so that they join together with subscribes. And this gives us the ability to save a round trip. We don't have to wait for a subscribe OK to come back and tell us where the subscribe is going to start. We can send the fetch right after the subscribe and say we would like this to join up against the subscribe that we just sent. So there's been some discussion so far. I just sent a set of updates. So let me see. Did I push the latest change? One more. Yeah, this didn't go through. Okay. Refresh here. Most of the discussion so far has been about kind of the details of the algorithm for how we determine where this join point is. And so this morning I made a pass at kind of revising and hopefully clarifying how that algorithm functions.
Mike, can you zoom in a whole lot?
Yes.
It's very, very tiny on people's
Sorry,
screens.
I forgot. I have a big screen here. So, and let me actually.
All right, that's
switch the other
at least
format
legible
too.
for me.
Okay, so mechanically, the mechanism that we're using to do this join is, rather than having a new message altogether, is to extend fetch by having a concept of fetch types. So there will be kind of the existing fetch behavior will now be considered a standalone fetch. And then this new behavior will be considered a joining fetch. So this is kind of modeled after the filter types that we have for subscribe. You just have a field here, and then you have some, optional fields that depend on which type of fetch you are performing. So in the case where you are performing a standalone fetch, you will need, track namespace, track name, etc. All the fields we already have. In the case where you are performing a joining fetch, most of those fields will be derived from the corresponding subscribe. So a joining fetch then has a subscribe ID that matches the subscribe ID of an existing, like an already sent subscribe. So you send a subscribe with, ID 4, and then you send a joining fetch with the same subscribe ID 4. And so because it's a joining fetch, we interpret that subscribe ID as a reference to the subscribe that we want to use to compute these relative values. And then the only other field that is needed in the case of a joining fetch is the preceding group offset. Previously, I had called this previous group count, but there was some feedback that doesn't really make sense in the context of non-contiguous group IDs. So hopefully this makes that more clear. So the preceding group offset is basically gives you this is the offset from wherever the live edge is or wherever your subscribe is going to start, and that's how far prior to that you would like to begin. All right, so this is kind of the meat of it, is how do we calculate that? So a publisher which receives a fetch message with fetch type of O2, so a joining subscribe, treats it as a fetch with the range being dynamically determined by the preceding group offset field value, as well as values that correspond, values derived from the corresponding subscribe message. So first we determine, for the subscribe that's already been sent, what's the state of content exists. And this is like whether our subscribe OK would come back having largest group ID, largest object ID or not. Then we can work out what a resolved start group is for that subscribe. So if we have a filter type of latest object or latest group, then it's just the largest group ID. I just realized there's an error in this next one. So I'll fix that. But then if you have an absolute start or an absolute range, then that's going to be your start group. Then for the resolved start object, this should say for latest object, it will be largest object ID. If it's latest group, then it will be 0. So I'll fix that shortly. And then for absolute start and absolute range, this is going to be equal to the start object field from the subscribe message. Does that kind of make sense to folks? So we're basically working out like where's the subscribe actually going to start? And that depends on, what type of subscribe it is and the state of the world.
Can I ask a clarification question?
Sorry, I was going to ask the same one maybe, which this is just describing subscribe behavior, which is independent of joining fetch, right?
This is just describing kind of the values that I'll reference below. So it is, describing the subscribe behavior, and then how we use that to determine where our joining fetch actually joins up.
Cool. And one clarification question along those lines is that, are we expected to send a subscribe before sending the joining fetch here, or like because you're using so it's like you send both at the same time?
You send the subscribe immediately prior to the joining fetch. without waiting
Okay.
for a subscribe OK.
Okay. Thanks.
Yep. Yeah, and if you I think it's above here somewhere. If you receive a fetch that has a subscribe ID, yeah, so if a subscribe ID does not correspond to an existing subscribe, then we respond with a fetch error.
Just another clarifying question. It seems like there's it's designed to pipeline, like you're saying, where you send
Mhm.
subscribe and fetch in this, like the client sends them both as in the same packet or whatever. But I don't think it's a requirement, right? Like I could send you a subscribe, and then at any time later in the universe, I can be like, hey,
Yep.
by the way, I want to join that.
Absolutely.
And like, here's a joining fetch for it.
Yeah.
Okay.
Yeah, there's nothing that precludes doing it sometime, further down the road. Will?
Yeah, I just want to make the observation that you can send the subscribe immediately followed by the fetch, but the relay may not have the stream it's subscribing to. So the calculations you're describing there may not happen instantly. The relay is going to have to itself make a subscription upstream, get the latest information from that response, might go all the way to the origin, and only then can it'll start acting on your fetch. But it'll still be doing it faster than if you did it yourself at the client, but it might not be immediate.
Right, faster, and yeah, importantly, it can
And
atomically
robust.
resolve where that join point needs to be. Colin?
This is carrying directly on from Will. So just so I understand correctly, so this means this information isn't learned until the relay gets at least one object in the subscribe, right? So that it has a view of its current view of the latest object, right? That's when this all happens.
Yep, and that's why content exists is one of the inputs to this algorithm. Because if content exists is 0, then what I'm suggesting that we do is actually forward the joining subscribe or joining fetch as a joining fetch to the upstream, so that it then doesn't even need to get resolved locally necessarily. You could just say, okay, you resolve that upstream.
Okay.
Open, yeah.
I need to think about that. Yeah, I can see pros and cons. Yeah, I see. Yeah.
Right. Yeah. Any other clarifying questions? Okay. So these are kind of the inputs for our algorithm. And then what we're going to compute is the range of the fetch. So start group, start object, end group, end object. Okay, so if content exists is not 1, meaning that largest group ID and largest object ID are not available, the relay should forward the fetch with the O2 fetch type, so joining fetch upstream. That's my proposal. Yes, Alan?
I put this question in chat too. So does that count cases where you haven't seen subscribe OK or an object yet? Like the subscribe came, no subscription, so the subscribe went upstream. Then I see the joining fetch, and I know I don't have any, like I'm still waiting for information on this track. Do I wait or do I forward the fetch?
This is why I put this as a should and not a must. I could see wanting to do different things here.
Okay, I don't know. Maybe that's fine. Relay is gonna do.
Yeah, that's kind of what I was thinking.
Let's come back to this. I think there's a variety of reasons where this is not going to work, where it's going to give you where sometimes you're going to get all the objects and sometimes you're going to miss objects as soon as you forward that upstream like that. So let's reason through whether that's right or wrong, but I'm pretty sure we wouldn't want to have a sometimes you get all the objects, sometimes you don't type behavior. And if that's the case, we'll probably try and avoid that, right? So
okay.
But that's more an opinion, not understanding the PR as it is. So
so I'll walk through this and then we can maybe try and reason out some examples and make sure that things make sense or find the edge cases that we need to handle still. So propose, forward that upstream if we don't have content exists. And then the fetch start group is going to be equal to the resolved subscribe start group minus the preceding group offset. And this is where it becomes relevant that this is just an offset and not a count. because this may not yield an actual group ID that exists, right? But all we're doing here is resolving the range for what would go into an ordinary standalone fetch. So then how you deal with what that number means is the same as how you would deal with it in the case that you had a standalone fetch. Fetch start object, always 0. The use cases that we are designing this for are use cases where you want to start from the beginning of a group. Down the road, I could see possibly adding other types of fetch that do different things, but trying to keep things simple, we're going to always start at object 0. Then we have this issue that we need to deal with, which is if our subscribe is starting at the beginning of a group, then we don't necessarily want to have an overlapping fetch, right? So if the resolved subscribe start object is 0, then the fetch end group is going to be the resolved start group minus 1. So we always want to make sure that we are the preceding group if we're at that beginning of a group, so that we don't overlap. And in that case, we will fetch all of the objects in that preceding group, right? We want the whole group. Otherwise, the resolved subscribe, if the resolved subscribe start object is 1 or more, then we say that our fetch end group is going to be the same as the resolved subscribe start group, so that we can get those objects that lead up to wherever resolved subscribe start object is, right? So fetch end object, the way that end object is defined for fetch and for standalone fetch is that it's the final object of the fetch plus 1. So by making it identical to the subscribe start object, it means that we will fetch up to, but not including that object ID. So that should give us, a non-overlapping fetch. And then this is the weird case. So if we have, and this can happen if you have a preceding group offset of 0. So you would have a preceding group offset of 0 in order to essentially say something similar to what we do with subscribe current group today, or a subscribe latest group today, where you're saying, I would just like, from the start of a group to whatever the latest object is. And if the latest object is not 0, then that's fine. You'll get, 1, 2, 3, 4, and then, 5 will be handled from subscribe and onwards. But if the latest object or your start object is 0, then you can end up with this case where the fetch end group ends up being less than the start group. And that's an empty fetch, which I think is fine. Like, I think that is an acceptable way of resolving this, so long as we have a way of signaling it. And maybe that's a fetch error.
In the past, we've said if you get no objects, you get a fetch error with an appropriate error code. So I think that's fine.
Cool. So that makes sense to me. And then
I had a question on delivery order. If you send a joining fetch, do you end the priority of the fetch and the subscriber the same? What do you get first?
Delivery order, if the priorities are the same.
Is it the same as 2 subscribes with the same priority, like implementation going to do?
You should get the fetch first, because that's what you want in your decoder, because temporarily it's media content that precedes the subscribe.
Yeah.
So the relay has to make a choice. It should send the fetch first.
I think we probably want deterministic behavior for this particular case, and not just server's going to do what server's going to do, because I think it matters. But yeah, I tend to agree with Will. But I just wanted to ask that question because I thought it was important.
Yeah, I think it is important. I'm also trying to limit the scope here to say, by saying that we just have an algorithm for resolving this into a standalone fetch, then we can say whatever the standalone fetch behavior is, like do that. So if we want to like define what that is, I think we should define it for like standalone fetch and just fetch in general, not this particular case. Yeah, and then the last point here is joining fetch is sent in ascending order, group order. Again, because that's the use case that we're trying to solve for here. We could, do different things, but for the sake of simplicity, trying to solve the problem that we have. All right, there's a little bit of a queue. Looks like Colin is first.
I was just going to respond to thinking about the priority of the data set, and it does make sense to reduce this to however fetch and subscribe work. Okay, I like that. That seems like a great design pattern. But I mean, I think on the joining fetch, sometimes you might want the priority of the objects in the same group to be higher priority than the subscribe, because you want to get them right away, because you can't play anything until you get them. But you might want the things in groups that came before that to be a lower priority than the subscribe, because you're really only getting them in case you want to rewind. Now, maybe that just means I should use two different fetches since I want two different priorities. Yeah, Alan's nodding his head. So, okay, so I was just trying to think, I guess I've convinced myself, I should have shut up. I've convinced myself through my head that we have a solution to this problem. So it sounds good.
Okay, yeah, that's also jogging my memory. That one thing that's currently not in the set of fields. Oh no, wait, it is. Okay, so subscriber priority is a shared field for both standalone fetch and joining fetch. So you can set that explicitly if you have a preference, and you can then set it relative to whatever your subscribe is, because you would know what that is. All right, Will?
Yeah, just scroll down a bit. The algorithm for fetch end group is the result subscribe group -1. That works beautifully when it's contiguous group IDs. But say they're spaced 1,000 apart, and the last one is 5,000, right? The preceding group ID is actually 4,000. But with this algorithm, you're going to ask for a fetch from say 1,000 to 4,999. Now the relay doesn't know that 4,000 to 999 don't exist, so it's going to force it to go all the way to an authority, maybe the origin, to figure that out. Is that acknowledged? Is there a way we can get around that? I think probably not off the top of my head. It's a consequence of non-contiguous group IDs, perhaps.
I think so, and I think I would rather resolve that separately. Like if we have issues that arise from non-contiguous group IDs, I think that's its own.
We have the same problem with a fetch anyway. If you ask
Right.
for 4,500 and the last one was 4,000, you have to go and find out if they're missing one. Okay.
Suhas?
Thanks. I think your explanation kind of making sense, and I joined in the queue to talk about the priority, and I think I'm also convinced. But one thing, like previously we called it subscriber priority because we didn't had fetch share with subscription for the initial fetch, so it was independent. It should be called fetch priority, but we use the same term because they're independent and you can specify. The one thing I was thinking would subscribe priority or the priority for this should be two different fields that it's not shared. Would it be that way you can basically say you can control fetch priority differently compared to the things that start from subscription onwards after that?
You do. So subscriber priority is a field of a fetch message.
But if you do joining fetch, it's shared for both, right? Both will have same priority.
No. The subscribe message has a subscriber priority, and this fetch message has a subscriber priority.
Yeah. Oh, okay. Sorry, I totally lost because you're sending a subscribe message as well. Okay, makes sense.
Right.
Then probably we should just call it fetch priority. That's the naming issue.
Yeah, I'm fine with that. I think probably the reason that we had it as subscriber priority was just to make it clear that they're in the same domain. But yeah,
Makes sense. Cool. Thank you.
Colin.
So if we're ready to move on from clarifying and discuss this issue of of how you handle it when there's no content, whether you upstream that, are we at a good point to move on to that discussion a little bit? Sorry.
Yep.
Okay.
I'm fine with that.
Okay. So what I'm thinking here is, imagine you have a bunch of clients all joining at the same time, and they hit the same relay, and they all do exactly the same thing. The same client, you know, they're all going to do one of these follows in the same way. The first one does whatever it does, and it'll probably work out fine, exactly like you're imagining. But the second one joins a little bit later, and the relay's already sent like what I'm worried about is the upstream, that the upstream relay will have a different idea of what the leading edge object is relative to doing this calculation than the downstream one, because there were some subscribes in flight and we aggregate the subscribes, right? So I'm worried with a bunch of people joining that we would end up in a case where if you forwarded this upstream, you would get a different set of objects than in the fetch reply than you would get if the first relay that got this just waited until it got its first object in the subscribe. And then once it had content, I mean, if it needed to do an upstream fetch, it'll do an upstream normal fetch for an absolute range of objects, but otherwise did that. So the case I'm thinking that could happen here, and I could draw it all out with an example of a piece of paper, but the case where because of timings between the two relays subscribed, basically you can end up in a thing where you get a gap of, yes, the first subscriber got all the things in the fetch, but the second subscriber missed one of the groups, the most recent group, because effectively their subscribe happened later than the other one.
Yeah.
And it just makes this just is hard to think about. It just makes me, from a reasoning point of view, want to put all the logic for resolving these ranges into the one device that knows them all and just takes care of it. And I don't, that's sort of where I was going with thinking of it.
Yeah, I think so. You've got a good point. The part of the thesis here is that in order to join a fetch and a subscribe, there's local information about what that edge is for the subscribe that exists only on the publisher, right? And you're pointing out that like different publishers have different views. Normally that's fine, but you need to make sure that you resolve the subscribe in the same place that you resolve a joining fetch, right? So maybe what we need to say here is like, it depends on whether you're going to forward the subscribe upstream as well. Because if you forward the subscribe upstream and determine where that edge is at, right, with the same local information,
so look, that's
it works out.
And that gets to my example. The second client joining will not forward the subscribe upstream. It doesn't even have a subscribe to reference when it forwards the thing upstream. So you have to resolve it locally if you're aggregating subscribes. So I can see that working, but this seems like a lot of complexity to add for I'm not getting what gain exactly we get. I'm not, I mean, maybe we should implement and see what it looks like, but I don't know. It's just sort of yellow flags for me.
Can you clarify, Colin, you're just talking about particularly around the behavior specified here.
Only one teeny part of, I love this whole thing. Looks great.
Okay.
One teeny part of the behavior here, which is when you don't have any content, what do you do? And there's two possible implementations. Punt the problem upstream, which is what this proposes here. And there is wait until you have content and then do exactly what's described here, right? Those are our only two like architectural options. And I'm seeing, it seems to me like there's some weird timing edge cases if we go with the punted upstream problem, but maybe not. Now, if we did what Mike was just proposing, is we say, if you send the subscribe upstream, then you punt it upstream. But if you don't send the subscribe upstream, then you deal with the local. Yeah. That's sort of like the combining both. That would work. I don't see any problem with that. That seems to work.
That makes sense to me.
But it just means for the second subscriber, it reduces to what I'm proposing, that you deal with it locally. And for the first subscriber, it reduces what Mike's what's in the PR there that's you punt it upstream. Any of those would work for me as solutions.
Yep, that makes sense to me. Well,
yes, I was saying a strong +1 to what Colin just said. I really don't think we should have normative language in our spec about how the relay should do this. The relay is going to be aggregating lots of data, and it might choose to make a big fetch, it might not. All we need to tell it is you need to match it to a subscribe, and we stop at that. Different relay builders can come up with smart ways to do it better or worse than their competitors. That's fine. But there's too many use cases for us to list them all to write normative instructions for how to do this. We just say what should be done.
Yeah, I think that's fair. The more we talk about this, I do think we should probably have non-normative language making recommendations that the subscribe and the fetch should be resolved in one place. Like spell that out at least somewhere.
That's good, guys. That's the whole point of this. I agree. We might have a little one-liner saying the resolution should be made on the same machine to avoid the time of flight affecting your information.
Sorry to jump to Q, but just to reiterate, I think a point Ian was making earlier, though, I think the client should be able to depend on the fact they are going to get all the objects eventually through this combination of things, right? Like we should say the behavior of the relay has to provide, not how to implement the relay, but in the end, the relay must deliver all the objects, and it's a consistent, dependable set of objects that you're going to get down on the clients, right?
Yeah, Ellen.
Yeah, I think the case I want to talk about is the case where I have subscribe okay, but content exists as false, which means my subscribe showed up before any data was produced in the track. I think in that case, you want to just immediately either fetch okay empty or fetch error empty, whatever it is, like, and assume that the first object that gets produced in the subscribe is going to be from the beginning of a group. So I think you don't need to handle this like content exists, like subscribe okay, but content not exists. I think you can just like your joining fetch is meaningless. You'll get what you need.
Maybe. So I think it depends on like what do we do in the case where you are subscribe latest object?
If you subscribe latest object, but the publisher has not published any objects yet, you're going to start at the beginning of a group.
I see. Because okay, so content exists as 0 in that case. Okay, you've gone all the way back already. Yeah. Okay. Yep, that makes sense. Mo?
I'm not too concerned about the determinism because I think it's a fake assurance. Most likely there won't be only one relay. Most likely all the clients won't be hanging off one relay. So determinism for a subset of clients on one relay, I don't think is critical in this case. And the important thing is that they get the data that they asked for. And if they asked for in preceding groups, they're going to get in preceding groups, even in your forwarding case. It's just that in preceding will be a different set for those, for the early ones versus the later ones. But more likely, they're going to be many clients on many different relays anyway. So that same problem exists for any real app. So I'm not too concerned about the determinism there. What I am concerned about is the complexity. And it seems like there's a lot of complexity. First of all, this is mandatory, I assume. This is not going to be optional for relays. It's mandatory behavior for relays, right? Mandatory message, mandatory, everything normative about doing this, right? So if it is, then, we started off simplifying subscribe, separating out fetch, and now we have, greatly complicated the join fetch to go back to the same semantics as the original subscribe. Are we any better off than where we started with this just as an option inside of subscribe? It seems like it's actually simpler the way it was earlier with just an option inside subscribe. This feels more complicated to implement for both relays and clients.
Mm-hmm.
I don't disagree with it. I agree with your functionality. I agree with this. This is a valid use case and that we want something like this. I just worry about the spelling of it. It feels more complicated than the original subscribe.
Yeah, I think where I see it as actually simpler is in the distinction between past and future, right? So if we're talking about, fetches for things in the past, whatever past means, it's going to be like a local, line in the sand. And subscribe is for things in the future. This allows for for that separation to exist and to say, okay, yeah, we want to start from, the beginning of a group, or we want to start this many groups behind. And those things are necessarily in the past, so they belong on the fetch side of that bifurcation.
But this is mandatory, right? So the relays have to implement all of this. That are you saying that the clients don't need that complexity? They could choose to only do simple subscribes and not bother with this complexity. But the relays have to do this, right? There's no optional element of this for relays.
Right.
Okay.
So time check. The 7 more minutes, I think, is what we have for this.
Thanks. Ellen?
Yeah. So as an implementer, I have not yet implemented fetch in my relay because I don't have a cache and I just haven't gotten to it. My relay is fairly simple. But I'm not overly assuming once I implement fetch, which we have to implement in relays, I don't think I see joining fetch as being more than about 10 lines of code in the relay. Which is just like, okay, I got a joining fetch, go find the subscribe that it's paired to, resolve it, and then call the fetch code. Like it seems like that part's fairly simple, but maybe you're talking, Mo, the complexity you're concerned about is just like, you just want to think about it as like, I'm just subscribing rather than I need to subscribe and joining fetch, and like maybe maybe it's a conceptual thing that you're more concerned about.
No, it's, like, it's the state management. The difficulty with the fetch is the state management, and we're stuck doing that, whether that is this join and fetch, or whether the reason we removed it, I think, from original subscribe is because state management got to be complicated when we thought, oh, we could simplify this, just a simple subscribe, boom. There's no state management. Everything is, cut and clear. It's only the new stuff that comes in. It's what you receive. It's not what you already had cached. So this, this gets you back to that state management issue, which we originally had before with subscribe.
I mean, I think that state management problem is like, that is inherent to the domain of the problem we're trying to solve, right? Like we know, like the original subscribe from whatever a year ago had all these different things because those are the things that applications want to do. And we struggled with how to deal with the semantics of what does it mean when you're asking in the past, and how fast does it come, and how do you apply back pressure there, and how do you prioritize it, and all those things that we solve with fetch, right? So, but like the application wants these behaviors of like, I want to join one group back. Like,
let me give you a concrete example of what I mean. So when the relay receives the subscribe, a real implementation is not going to act. It's going to peek ahead to the next message and see, is the next message a fetch join to see, should I serve what I already have out cached first before I serve the subscribe? So in real implementation, there's going to be this stateful, resolution that's going to happen on relays. And it means you're going to peek ahead into future control messages to make sure you don't make a bad decision. Because if you do everything just, as you get it, you're going to make the wrong decision. You're going to start forwarding subscribe, live head when, oh, wait a minute, the next message is fetch. Let me go back and send him the first objects that he should have sent. So there's a long queue and not much time.
Yeah.
I don't think that's how I would do the relay, but I also don't. My relay is not real, so I don't know that I can speak authoritatively.
Yeah, I'd like to keep going through the queue. Ian?
Thanks. I'm thinking through this, and honestly, this feels more like a mode on subscribe than it feels like a way to join fetches. And I want to walk through one particular example that I think is interesting. At least I think, well, I don't know. I think it's interesting. You can find out. Which is, so I do a joining fetch. And at the moment that I start the joining fetch and the subscribe, head is wherever subscribe says head is, right? So say I join 30 seconds to the past. So by the time I get to head, it is now 30 seconds in the future, and there's 30 seconds more content. Does that content get delivered on a single stream, or does that content get delivered as subgroups?
Nope.
Because I think it getting delivered as subgroups is problematic, because now we go back into the, like, we have no back pressure. And so the farther you go back, the more you get yourself back into a situation where there's, like, we get back into the exact same problem we had with fetch in the first place. Anyway, I mean, maybe this is a problem that already exists in the draft. I just want to call out that like this exposes like a new issue, or makes it clear that there is an issue potentially around back pressure when you subscribe to something far enough in the past, I think. Right. Does that make sense or no?
So a fetch currently is handled contiguously, not delivered as streams, right? Like separate.
I was actually saying the opposite, which is I think the data that is arrived for the subscribe should actually be delivered on a single stream as a continuation of the fetch.
Of the fetch.
Or maybe it should. I don't know. Like, because now it's like, now it is behind live by like a substantial amount. Or maybe it shouldn't be. I don't know. Like, I think that's a problem we need to like sort through though. And I think it could create flow control challenges. I mean, I'm fine with just saying like the server can do either or something, and saying like the server can pick. And so like if it's a little bit behind, it's no big deal. But if you go an hour behind, then by the time you get to live, like clearly like, a lot of things have been published. Anyway.
Yeah, the intent here is to handle primarily the cases where, that extra round trip is going to be problematic to wait. So I think we could potentially put some bounds on like what we think is reasonable for the joining fetch, and then say, if you want to go further back, you just wait for that subscribe okay, and then you'll know the offset to like make another fetch that goes back further. And then that'll at least like limit how much, subscribe stuff is coming, not in a way that we can have that back pressure. All right, we're running short on time. But I think Ian, you're the other presentation. So we've got 2 people in the queue.
I was just going to say, like, look, it's always tempting when you look at the request part of this to be like, oh, we ought to merge these 2 things together because they're so tightly related and they barely matter. But it's the data plane where everything separates. And like, this is much different than what we had before. We have 2 different priorities. We could set the priority of fetch higher or lower, right? It puts the fetch is being delivered over one multi-channel. So I think this gives us, it may, I mean, Ian's point's totally right. If you did a fetch way back, what would happen? But if you set your subscribe priority higher, you'd be getting all the subscribes while you were getting that fetch data. If you set it lower, you'd get all your fetch data left. I think this really allows the application to sort of pick its poison where there's really no right answer. And that for the most part, again, this will only be used for an extremely small look into the past, because you don't need to do you can do a non-joining fetches if you're interested in data that goes farther in the past than like really quick.
Exactly.
So I think this meets the use cases we sort of needed. And I think that separating up what's happening on the data plane with how the data is delivered after this is really the benefit for splitting them into 2 previously solved problems versus combining them.
Thanks.
Me.
Martin?
As an individual, this is related sort of what Ian's saying, but I think like to just say like fetches in the past and subscribes in the future, like that's conceptual tool we have, but like it's not the real like meat of the issue here. Like it's the flow control bit, as Ian said, but also like are we having like truly reliable delivery in order delivery, or are we having this like sequential like partial reliability thing where like we just chuck subgroups when they're too slow? And I think what we really have to answer here is what is the correct requirement for this like join 3 seconds ago thing? Are we trying to get subscribe like behavior where like if it's too old we're just going to toss it, or are we trying to get it reliably? And if the answer is the former, we should really look at just allowing subscribe to go back a few groups, not to 0, not an absolute number, but like a few groups, because what we want streams. If that's not the answer, we actually want all those objects, no matter how long they take, then fetch is the right answer. And I think that's the high order bit to resolve before we get into the mechanics of this. And to be clear, I don't have an answer as to what the right answer is, but that's what we have to answer.
Okay. I guess my question,
high order bit like in hours and hours of meetings multiple times. That's a question to the chairs.
Yeah, I mean, okay. So just as an implementer, like I think we face planted on this, like how to subscribe in the past work so many times that like, at least it's like, it may not be optimal, but at least the way we've done it with Fetch is tractable. Like I know how it's deterministic. I know how it's going to work. It may not be optimal, but like, and there's a use case, like strong use, like Mike and other folks who've brought joining Fetch, I think are, because they have a face and they do want everything. And so it like kind of doesn't hurt that I assume that they're not getting this like partial reliability construct as they're joining. That being so, like again, as an individual, I'm a big advocate of like we need to get rid of subscribe if anything in the past is just like not defined, because we have not defined semantics for it. If we think we need to, I think it's gonna, like Colin's saying, it's gonna take a longer time.
Yeah, but I don't think we're gonna get further on this topic today, but it sounds like we have still quite a lot to discuss here. So I don't know on the high level if we actually, is it high level enough that a mail thread or something, or do you prefer that we discuss this over the PR? Mike?
Well, Mike, do you have any takeaways from this? Do you have any action items from the discussion so far?
Yeah, I guess I'm trying to work out. It seems like your question, Ian's question about, okay, how do we, like, what semantics for delivery do we want at when we're joining a stream, is kind of a key question that has some bearing on, like, do we go this route? I think it's one that we've discussed previously, and we kind of said we should have a go at this. So my preference personally would be to try this, say, okay, here's an option. We can explore this. I think the other questions were either things that apply to like Fetch as a whole and therefore don't necessarily impact this PR specifically, except indirectly. And then there are a couple minor things that I need to resolve, like spelling out, what we do in the case where content exists is 0, when we forward upstream or don't, or rather saying, okay, the important thing is these are joined together atomically. So I have a couple minor changes that I can make. I think a lot of the discussion that remains is maybe not directly related to this. At least that's my takeaway.
Okay. So I'll just say that, like, because I don't have an opinion on this, I'll say as chair, if no one actually thinks that if anyone thinks you should get the past as subgroups, please put it in the GitHub. If not, then that question is answered. And a lot of people think it's already answered, so that's fine with me. Yeah, please take a look at it in GitHub. We're going to and just keep the discussion going there. Now that you're aware of it, you've been introduced to it, and then Ian will judge when that settles down. Yes, Alan.
Would it be helpful to take the temperature of this group in terms of, like, are people, like, Mike will make the revisions that he talked about, post another version of the PR, and we will generally proceed with land and try, or this is, now that we've seen it spelled out, we think it requires further discussion? Or, I mean, would it taking that temperature be helpful here, or should we just?
Yeah, if we do it quickly.
Okay.
All right, so let's just say, let's do a show of hands, I guess. If you think that this is a good basis for further discussion, is that the question you want to ask?
Well, or like,
Just
Yeah,
can
like,
we
are you,
merge
like,
the PR
is this-
with a few small changes?
yeah, is this
module-
PR close to what you want to see, or
Okay.
you want to see something different?
Okay, is this
Apologies
mergeable
in
minus
case You
nits?
don't like my question at all. Got a better one?
I
Go
was
ahead,
gonna
Will.
say,
I was
After
voting.
Mike
That's
makes
all. I
these-
thought he said put your hand up.
Sorry, I was gonna say, just like, it's a different one, was just like, after Mike makes the few edits that got discussed on this call, like this looks like it should probably be ready for, we'd be in favor of merging it or something close to it.
Okay, fair enough. Is this all right? So if you believe this is mergeable minus nits, raise your hand.
Yeah, I think just like to add one more point on Colin. Like, this is the use case we wanted to solve for a while, and this solution is not too away from what we want to achieve. So I think we need to kind of make it more address those needs. I think we are in a good shape.
Okay, raise your hand, please, if you think this is mergeable minus nits.
I'd like to defer my vote to Martin since he's actually writing the code.
I'm not going to vote, so that's a bad move. All right. Let the record show that 5 people think this is mergeable minus nits. Lower your hands, please. If you think this is not mergeable minus nits, please raise your hand. Okay, there are no objections, so I think that's a pretty strong green light to move forward with this. So Ian and Mike, you can iterate on this. If you have more comments, please do it in GitHub. All right, we have 7 minutes. Ian, are you ready to talk about
Yes, I will present.
remove group order for subscribes?
This is
This should be a quick. This is either a quick one or a very slow one. If it's a slow one, we'll abort.
yeah,
because,
I think. Well, it'll
I
be a
think I was-
self-solving problem because we have 7
that
minutes.
was the position. Okay.
It will. So yes, thank you so much for writing this. This has been suggested a few times before. At first, I thought we needed group order and subscribe, and then I realized I couldn't possibly think of a use case where it's actually useful. And I do think, from an implementation perspective, if you're trying to optimize, like say the CPU utilization and like cache efficiency and all these things of subscribe, like having it always go in forward order makes a lot of sense. So I guess, does anyone think this is a bad idea? Let's start with.
I do.
Okay, Victor, can you tell me why you think it's a bad idea?
We tested descending order in our test and it seemed to work and improve things.
Can you
It
say
does
more
work. It
about the
works.
test or the use cases that were the conditions under which it looked better, or like what kind of application?
Live video, no timeouts.
Isn't that more of a fetch use case?
No, that was for live video.
Okay.
So Victor, it's always unless there's congestion, it's always delivered in order, no matter even if you specify reverse order. So what was your congestion like in the test?
I tested different conditions, but the important thing is including the one like persistent lack of bandwidth.
Were you using the delivery timeout feature at the time or not?
No.
Okay. Because that seems kind of like a game, like without that feature, then I can see the use case for the group order, but like with that feature, it seems like that should provide the behavior that clients want.
At least my implementation is with delivery timeout and ascending order under congestion, where that worked well compared to with the descending order.
I mean, there are definitely cases when doing descending delivery order has weird consequences because you keep like chopping off like one frame or 1 or 2 objects at the end of a group. And so like there certainly are cases where it doesn't work as well as delivery timeout. But I don't know.
Are there objections besides Victor?
Well, I mean, I guess I would say if Victor had a strong use case, or if somebody feels really strongly about this, I don't see this as a huge implementation burden on the. I mean, you're sort of doing the same thing for fetch anyway, which does need this. Like,
All right,
somebody really wants it, it's not a big deal to leave it to me. Is I guess what I'm trying to say.
I'm not suggesting to land it. What I'm saying is that maybe Ian and Victor can have an offline conversation about this and try to reach a meeting of the minds. And then if like Ian is convinced that Victor's use case is valid, then we can kill it. And if not, and if the reverse happens, then it sounds like there are no other objections.
Mike has a hand.
Yeah, I've got my hand up. I would need to reread what I wrote a month ago. But I did have an objection on the original issue that kind of spelled out the scenario of behavior that you lose if you remove this that is not handled by the delivery timeouts alone.
All right. Yeah, this was I think this is what it's going to take a moment to read all this. I was going to comment that in the joining fetch case, we decided that could only be an ascending order. It seems weird to have an ascending order joining fetch, joining a descending order subscribe, but maybe that's.
That is
I'm like, my brain is trying to do like jumps. I don't know. I'm just putting that out there.
that.
And just one on the context, one of the whenever we discussed about the priority algorithm, also the group order was one thing that was never. It was one of the point of discussion on how to fix the priority algorithm, and that was one of the reasons as well. Like we didn't make much sense for subscriptions either. So just to add to the context of why we are at this place as well.
Okay, it seems like this PR is now on the slow path. Let's try to reinvigorate the discussion in GitHub. Ian, if you want to do an offline discussion with Victor, that might be helpful. And if we are ready to go talk about this again at the next interim, that's great, or at any other interim. Our next interim is January 8th. If you have not signed the blue sheets, there's a link in the Google Meet chat and in the Zulip chat that allow you to do so. I think Magnus, if not somebody else, added a bunch of you, but please make sure that information is correct. And anyway, check if your name's on the blue sheets. If not, Victor, yes. No, Alan.
I just, since it's the last meeting of the year, just wanted to say thank you to everybody who's put in a lot of energy over the course of this year. I'm about to write sort of internally like a state of the MOQ post, and I look back over a year and like we have gotten a crap ton done this year. So thank you everyone for. I know we at times like get in each other's faces about it, but like it's been a lot of work, and I feel like it's coming into a very good place. So thank you everyone, and have a happy New Year.
Yes, everyone enjoy your holiday, and you get for the holiday you get 30 seconds back.
Merry Christmas, thanks everybody. Thank you all. Good to see things are progressing. Bye.
Martin, do you post the notes so I can go?
Yeah, I will.